Hello, everyone, and welcome to Time Machine Organization's third webinar in a row. Over the past 2 weeks, each Monday, we presented to you one of our parts of our operational plan, our objectives. On the first Monday, the beginning of October, you were able to learn a bit about what our local time machine projects are about, how we try to set them up and give you the chance to share your content with us. The following Monday, we had a presentation about the services for members and also for third parties, which also leads to how we can support time machine related projects in the process of writing, of finding consortia and everything. And today we will have another interesting topic that will show you, or we try to show you, how we intend to actually build up the infrastructure and how to bring the time machine to life. And so we have invited our president, Frédéric Kaplan, president of the Time Machine Organization, and our chief technical officer, Daniel Jella, who will be hosting this today's webinar. As you should be used to already, we have a question and answer tool on the side. You can post questions anytime you like, and we will collect all of them and try to answer them after the presentations of our two main speakers. This event will be recorded and available freely online after we're finished. So that would be it for me. So I will pass on and give the word to our president. Frédéric, it's your turn.
Thank you, Caroline. I hope you're all hearing me well. So yeah, it's the occasion of talking about the time machine agenda and this concept of RFC, and more than anything else, it's the occasion for you to understand how you can participate to the long-term planning of the time machine. I will start with a concept you should be familiar with now, which is the concept of big data of the past. It's a kind of concept we've been using since the beginning of the project. It's a very simple idea. There's a lot of data about the present, and the more you go down in the past, the less data you may have. So this is what we call the information mushroom. And one of the goals of the time machine is actually to enlarge this mushroom through massive digitization. I mean, bringing new documents and new data associated with them, and also through other types of processes like simulations, filling the missing gaps and progressively making denser and denser representation of the past. So this serves as a guiding steps. The idea of enlarging progressively this mushroom, and the general infrastructure of the time machine can be represented in this way. I mean, as a general process that starts on the left, where you have documents. I mean, that could be, of course, archived documents, but also elements taken from videos, from urban measures, 3D scanning, and so on and so forth, which are let's say, analyzed by semi-automatic processes, what we call digital content processors, and which are progressively leading to denser and denser knowledge graphs, which get injected in that huge cube that you see at the center, where progressively, I mean, this data gets connected with one another and result in various forms of, let's say, densifications. And we've been theorizing and preparing the idea that there were 3 types of engines that will actually act on this, on these big data of the past repository. Some linked with 4D, what we call the 4D simulation engine, some linked with the transformation of textual document into images and vice versa, which we call the universal representation engine, and what we call the large scale inference engine, which is a way of testing the overall coherence of the data, detecting incoherent element, potentially also making inference about what can be deduced from existing data sets. So there's a form of continuous ingestions of data and continuous recontextualizing in order progressively to build not only denser and denser representation of the past, but potentially more and more coherent representation. And in parallel, you have what you have on the right here, which we call the access platform, various forms of interfaces to look at this huge graph of data from different point of view, depending on whether you're in maybe the academic domain, maybe if you're in the touristic world, maybe you are interested with a particular view on the data. These are different projections of the data, if you want, for particular domain of use, and they are thought as different perspectives on the data themselves. 2 weeks ago, Julia and Isabella showed you how the logic of the local time machine, which is a way of immediately, let's say, contributing and starting to experiment with the time machine infrastructure, is the idea that there are projects that are dealing with a particular municipalities, a particular region, and that these projects can collectively experiment, share their code, share their data, and actually manage to solve part of the problems of the overall time machine building by experimenting concretely with a rather, let's say, a short-term loops in order to have immediate effects. So the general schema for this collaboration is the following. Essentially, projects are created dealing with some aspect of a particular municipalities, and this project can be about data extraction, dealing with a particular source that will actually lead to some form of insertion in what we call the data graph, or they could also be linked with the creation of specific operators, which are elements of a code library that gets more and more rich over time, or they could also deal with particular apps. Search engine, for instance, is an app, an annotating system is an app, various way of visualizing or transforming the data are apps, which are directly impacting on two of the main structure of the time machine, which is the 4D map and the data graph. So these are ways of immediately experimenting, immediately sharing, and having feedbacks on what is actually concrete working examples based on local situations. The thing I would like to talk today with Daniel is the longer term. I mean, how do we progressively scale up from these local experiments to the actual building of the infrastructure that I showed up very briefly a couple of minutes ago? And for this, we decided to take inspiration from the building of another very big machine, very complex to build, a global machine, which is the internet. I mean, for more than 50 years now, the internet have been using a process for collectively agreeing on standards, for collectively finding solutions to very complex problems, which is modestly called the request for comments, but which has been, in fact, the skeleton of most of the internet standards so far. And we thought to take inspiration, modifying a bit, I mean, the logic of the request for comment, but actually taking inspirations from that mechanism to progressively come up with a process over 10 years or so to build the entire time machine infrastructure. So that was one of the main output of the time machine CSA project, which was run last year, supported by the European Commission. And we plan about 68 RFC to be written. So an RFC is essentially one problem that needs to be tackled and solved in the time machine infrastructure. It could be the description of a particular component. It could be also a particular way of evaluating results. It's not an academic paper, but it's always a technical or practical solution to a problem. In fact, each RFC starts with a motivation explaining the problems to be solved and come up with a particular solution. So how does this collective RFC works? Well, there is what we call an editorial committee, which is managing the process, which is mandating authors, or authors could also volunteer to the editorial committee to write RFC drafts. RFC draft is essentially a proposal for solving either an already identified problem or maybe a new problem which needs to be actually resolved. And these RFC are written through a process of reviewing that we will go into detail in a minute. They are reviewed first locally by the RFC team to make sure they are coherent with the global infrastructure, and then at the second stage by the community or larger community through a process which has some similarities with the way a paper is reviewed. That permits through this process of various circular reviewing to really build slowly a form of consensual view on that particular pieces of information. One thing which is very important, and which is the role of the editorial committee, is to monitor and keep up an updated version of what we call the RFC trees. So the RFC trees is the dependencies between the different components of the time machines. This is something which is not fixed. I mean, we have a first version of the RFC trees, which is the result of this time machine CSA project. But actually, obviously, as new RFCs are written, there will be sub-RFCs, new RFCs to be written based on the problem which has been partially solved. And so the RFC trees gets updated, which permits to publicly know what is the current stage of the planning of the time machine and what are the problems that needs to be solved. So this is the essential cycle for editing a draft and progressively making it part of the RFC tree. It's all going on through the writing part using Github. I mean, we thought, but Daniel will say a couple of words about this too, that Github has shown, I mean, as a way for dealing with very large and complex planning process, its potential for having the right, let's say, possibilities of, on the one hand, control and on the other hand, opening of complex processes. And you can already go and see, I mean, on the GitHub page for the Time Machine project, the current stage of drafting of the RFCs, and the first 5 RFCs in particular, which are currently for 6 RFCs, which are currently at different stage of production. Essentially, the thing which is interesting, the RFC process itself is defined in the RFCs. That means the RFC 0 is the first description of the process I just mentioned, and it could be itself updated if we think the process is not good. The RFC 1 is an RFC which is going to be updated very regularly, which we call the Time Machine Glossary. It contains all the definition of the terms which I've been using, for instance, in this presentation, but of course that will get updated as the time machine gets developed. The RFC 2 is the RFC containing the current description of the RFC tree. So if you want to know exactly what is the current planning, what are these 68 first RFCs, you can go and see the RFC 2. And then you have a series of subsequent RFCs which are describing the editorial committees, the platform which are used for monitoring the RFC, and the first, let's say, content RFC, which is the RFC about local time machine, which is the RFC 05. I'm almost done. I just want to stress 3 things: that we now really need to recruit new people, motivated people that want to participate to this adventure, this collective implementation and of the time machine. We need, for the moment, really 3 types of people. We need RFC editors, typically people which are really interested in the process itself, that wants to go a bit deep about the structure of the RFC trees, the planning, but also ideally that mastering the GitHub platform, so that could help Daniel and myself monitoring and making actually the dialogue with the authors. So if you are that type of people, please contact us. We need RFC writers. I mean, if you're, let's say, specialist of one aspect of the infrastructure and you think you have the right solution for some pieces of technology that you will see in the RFC tree, well, that's a good moment to signal yourself, and we can discuss then on that basis whether it's worth that you're making an actual try to come up with an initial draft. We're trying to help that process so that nobody is losing time, and that maybe teams of writers can join immediately to come up with as relevant version as possible. And we need even a larger number of RFC reviewers. If you don't feel like being an editor or being a writer, but you would be happy to help actually pointing out the flaws or the problems or what can be improved in existing RFCs, well, please actually volunteer for being an RFC reviewers, and from time to time you will have actually to officially judge some of the RFC which are being written. A single address, if you want to volunteer for all these posts, is rfc@timemachine.eu. And we hope that there will be many volunteers for joining us in this adventure. I now give the floor to Daniel, which is going to go a bit more into detail and how actually the GitHub platform works for this collective RFC writing. Daniel, you can come.
So So, hi everyone. I'm very glad to be here this evening and to show you something about the technical details. Not too detailed because that's a very complex subject, but I give you a short tour de force, if you will, through the process of creating and discussing an RFC. And hopefully, in the end, some of you will see it in your own interest to maybe join us, as Frederick already said, in position of the various people that we need to continue working on the RFCs. Okay, so hopefully you should see my short presentation where I will give you a short outline on the technical aspects of the whole thing. That will be rather short, but then I will go into the live thing and I will show you on GitHub how the whole system looks and what you can see right now if you visit it yourself. Okay, so, and first let me summarize a bit what RFCs are from a technical point of view, in addition to what Frederick said before. RFCs are individual documents on a specific topic. They are written in a specific technical dialect called Markdown. That's a very simple form to structure texts in a way that you can create PDF documents out of them in the end, but still they are readable as source code without big difficulties. They are treated basically as source code in our GitHub repository, in our Git repository. They have a fixed identifier that they get assigned in the beginning, in the idea stage. So whenever you see an identifier for an RFC, you know exactly what it's about, and you can go to the GitHub repository and see exactly the history of this document. We have these individual authors that will write this document, but at the same time, the community is encouraged to also contribute in the form of discussion, of feedback, but also in the form of concrete change suggestions that will also be visible and will be tracked in this source code repository. At the later stage, these source code documents, if you will, get converted to formal PDF paper documents that will be uploaded to a peer review platform, just as other scientific papers, and they will be judged by these reviewers that Frederick mentioned before, and if they are accepted, they will publish on a publishing platform that is not directly inside the Time Machine organization, but where you can find other open access papers, data sets, and so on. So in the end product of this RFC process will be real scientific papers describing specific facets of the time machine. Okay, so how does that look like? We have these different stages in the RFC life cycle. Of course, the first stage is we get an idea for an RFC, we find an author, and the author or the authors, of course, prepare their initial draft in whatever software and environment they prefer. After they finish this draft, they give it to us and we put it more or less into the GitHub repository, and we will start with this community review and improvement phase that will be happening solely on GitHub. Then after this phase will end, it usually will take around 2 weeks where people have the possibility to comment and to suggest improvements. It gets into this formal review phase on openreview.net. And if the paper is accepted, of course, then the paper will be presented to the general public and will be part of the official Time Machine request for comments tree and part of the, as we said, the code of law of the Time Machine. Okay, so we chose GitHub as a tool. It's more or less the biggest social source code management platform. Many big open source projects, but also digital humanist projects, community works, and so on, are hosted there. It's on the one hand, it's the possibility to just store and document source code and changes to the source code, but on the other hand, it's a tool to socially collaborate in working with these documents. You can suggest changes, you can submit your changes yourself, you can make a copy of the document, change it, and then suggest the new version to be integrated in the software. You can create issues where you can discuss with all the other collaborators things that you wanted to improve in the code. And in the end, we can also make automated actions that transform this document in PDFs and upload them somewhere and so on. So for the time machine request for comments process, it gives us the possibility to thoroughly track the whole history of a document, who contributed something, who made changes to specific parts. So the whole process is transparent. That's very convenient for us, and it also is a very well-known way to contribute to documents like that. So there should be many people able to use that kind of system because they use it in their everyday work. So that's a good thing for us. And the second phase on openreview.net, we chose that because it's also an established platform for peer review processes. You can describe the whole workflow of having a paper peer reviewed. It's fully transparent how it works, who's was in favor of the document, who had some objections to it, and in the end, the paper will also be accessible at later points. So all this means that people who might not want to contribute on GitHub because they are not familiar with it or they don't feel comfortable with it, have a second way to still get the results of the request for comments project process and also participate in this project. So we have these two different facets. For today and for the next few minutes, I will concentrate on GitHub because that's the step that we have most thoroughly developed already. Because if you visit GitHub and our repository, you will see the address later on. You will see that this process that I described just now is also part of the whole request for comments process. So we have a bit of a chicken and egg solution where we use something that we at the same time are still developing. So you can see the current state of the project. And yeah, well, okay, I will just switch to the real deal. Hopefully everything will work. I think you should still see my computer screen. If you visit this address, github.com/timemachineproject/requests for comments, that's the official request for comments repository. You will immediately get access to the whole process, to the whole documents. At first, you will see an overview over the current stage of the request for comments. Here you can see we have currently 2 requests for comments in the stage of preparation. So these are not yet finished in the sense of drafts where we can contribute. These are still in the process of being written by the original authors. And we have several requests for comments that are already since Friday, I guess, in the process of drafting stage. So if you take a look at these documents, you can, if you see something, give us immediate feedback. As you see, these are all links. So I will just show you the different steps of drafts. So more or less, as soon as an author starts preparing one of these requests for comments, they can make it accessible if they want to in the form of something that's called pull request. Don't worry about these specific terms. We will at a later point make a workshop and give you more documentation on how exactly to contribute on the specific stages and what the specific parts mean in detail. But basically, these are established terms in GitHub. You can look it up what it means, and of course educate yourself. We do not really diverge from the general way to do that. So people can create a pull request. That means they have a version of the document that they want to make available in our system. That gives us a formal way to see the changes and to discuss several parts of the document. So you could give a suggestion to the author that they might rephrase something. So we have the parts where we can see the original files. Also, we can see what gets changed from the original document, what gets added. So you can see here, the document in the beginning is a template that is not really personalized to the request for comments yet. And Frederick, who was authoring this request for comments draft, or is authoring, for instance, removed this line where it says author one. Maybe I zoom in a little bit so you can see something. So this line author one got removed, and these several lines with additional authors got added to the document. And so you see the whole history of the document is visible in this thing. At the same time, you can see the initial steps that have been taken. So at the 22nd September, the initial draft was submitted, and then immediately an additional commit was made on also the 22nd September. And you can see what got changed during that specific, it's called commit. So basically here, just the initial version of the document was added, and this template that we provide authors with got removed. So that's not very complicated. And this is already visible to everybody, and feel free to comment on everything if you see the need to. So you could write a comment pointing to specific parts of the document, giving feedback on things that you might see as not completely understandable or incorrect or whatever. So this is the first step. A document gets prepared by the initial author and gets submitted to us in the form of a pull request that is not yet official, but it's still already visible and we can track the changes. Then as soon as this process is finished and the author considers the document good enough for this initial discussion by the community, we will accept this pull request and make this document part of the official code in this repository. And that's what you can access if you just initially visit the repository. You can click on files, and here you see a draft folder, and in this draft folder you will see immediately the currently prepared RFCs and the ones that are already in the process of being drafted are visible, and the other ones that are not yet in the stage of drafted are still present in the form of just more or less empty templates. So you will see the current stage that the documents are in. To ease the access of these documents, we have put links on the starting page of the repository. So basically, for instance, if you're interested in the current state of the RFCs 3, and if you would like to contribute to the document either by making additions yourself or by just creating comments on it, you can just click on this link here and it will take you directly to the document itself, and you can read it if you want. It's markdown, but it gets rendered as HTML document, so it looks a little bit different than the PDF that gets produced in the end, but still it will look more or less the same. You can read the document, see the diagrams that are included and so on. And if you're interested in the additional documents, you can visit not only this initial file, but also all the images, the various different stages of the images are also part of the repository. For instance, here, that's one of the images that is used in this RFC document. So as you see, the whole different stages of drafting are inside this repository. And if you, for instance, would like to add a comment to anything in this repository, you click on this menu icon called Issues. Issues is more or less a technical term for everything that you would like to discuss or would talk about with an RFC. In software development, it's usually used for either tasks that need to be solved for a program or bugs, for instance, that need to be fixed, and you can discuss something like that. For us here in the context of the request for comments, an issue is just anything that you would like to discuss in relationship to an individual RFC. So you can see here the headline. That's something that I just added myself. You see a label, so you can see that's about RFC 3. You can click on it, and you will see that I wrote a specific section in the RFC could be improved a little bit. And immediately you would get the possibility to add a comment. For instance, if you agree with the text that I described, or if you disagree, you could say, no, I think that's fine. I would like to have an addition here and there. So it's a little bit similar to a chat platform or comments on Facebook and so on. So really, you have the possibility to immediately discuss the various aspects of individual RFCs. And if you would like to make some changes to the actual RFC, you can do so as well. The workflow is a little bit more complicated, of course. I will show you a small glimpse to it, but for you it will work a little bit differently, and it will be the content of a later workshop where we show it to you more in detail. But just so you see how this will look in the form, you can just click on edit this file. For instance, of course, you can also download it to your computer and use several versions of different softwares to edit this document. But here you can see the raw source code of the document. You see here there are some images included. Things with these two arrows are written in bold and so on. These are headlines. So you can just make some changes, and after you finish these changes, you could, I won't do that for now, but you can just commit these changes to the repository and give it to us in the form of a pull request, and we will see them, and they will, if they are accepted in the end of the review process, the text will be connected to your name. So your contribution and the contribution of everybody working in that sense with the documents will be visible. So after some time, this review phase will be finished, and GitHub will prepare documents from it. You can also access these sections if you are signed into GitHub, and you can just download the PDF files that get created. I will just show you some. Hopefully I will. Yeah. So that's what the RFCs in the end will look like. This markdown document will just be converted into a usually into a PDF paper, just like any other scientific paper. You have these images. There is a serial number connecting it to the individual commit, and this will be the thing that at a later point will be uploaded to openreview.net, and that's what reviewers will use to review the request for comments. But this specific part is something that I will also, I can show it to you a little bit, but that's not yet completely finished. We're still in the process of drafting the peer review part, but still, it already exists. So the time machine organization also is part of openreview.net. We are a virtual venue, and you will see here the individual RFCs as submissions. That's just something that you see here. It's a test that we did to see if the system works for us. And in the end, you will see the different reviews by different reviewers. Caroline was so nice to do the test review here. You see the rating, confidence, and so on. Just like in additional, in similar cases where you would submit a scientific paper to a scientific journal. And you can, of course, just download the version of the paper that has been reviewed in this document, in this submission. And what we will get from that in the end is a finished, peer-reviewed scientific publication that, as I said already, describes an aspect of the RFCs. And yeah, that's very complicated, I guess, and it was really a short overview, but in a later point, we will show you everything in detail. We will hopefully produce videos and everything. So that's, I guess, what I would like to show you now, and I will give back the floor to Frederick, and we'll see what you have for questions for us. I guess many.
Thanks a lot, Daniel. A bit of echo. Okay. Yeah, so maybe also before just answering the question, to sum up, I mean, there are different phases. You can write your RFC and prepare the RFC a bit the way you want. Then they become an actual draft and are discussed on GitHub. And then once this is satisfactory, they get reviewed on open review. So you have a bit these 3 steps of the progressive maturation of the RFC. It's nothing in any case is set on stones. I mean, everything can be changed anytime almost, and you have access to the actual state of the development of the time machine. Let's see if we have some questions. I see one question here about whether GitHub is the only place to manage and publish RFCs, whether we could use potentially other platforms to do it. Well, there are a bit 2 answers to this. One is that this is still in the process of being defined. So we are organizing this webinar at a very early stage. I mean, for the moment, essentially, it's Daniel and myself, which have been, with the help of Mike, Andreas, and a couple of others, setting up, I mean, the early stage process. But the platform for RFC editing is actually the subject of an RFC, which is the RFC 3, which is just published as a draft, but not yet reviewed, and so there's possibility here of let's say, making still this question discussed, and or if we are all convinced that GitHub is better, to make it clearer why it's better and why. The thing which we should explain clearly is that there's a very big difference between the tools you may use to actually prepare a draft RFC. I mean, you may work with your co-author in any tools which permits very agile way of collective writing. And then by the time you enter the drafting process, here it's a slightly slower process where each addition, each modification is very important to track it, to discuss it, and to see it in a slightly less agile way. So there's a process of progressive sedimentation, and we're trying to find the best tools for doing this, but the discussion is open. This is the subject of the RFC number 3. Any other questions? I see there's a questions on whether we could have an RFC on standards for publishing ground truth. There's no, so the idea that, I mean, in the website for local time machines, you have the possibility to publish data sets. And it's true that today the standards for these data sets are not fully defined. I mean, there's a couple of initial proposal. We have one of the central RFC of the time machine, which is the RFC 18, which is about the data graph. I mean, ultimately, we would like to collectively agree on the standards organizing the system which is permitting the convergence of all the data which is extracted from all the documents. There are many standards out there, so it's a complex question. It might be possible in an intermediary stages, if we believe, for instance, reaching a consensus on the data graph that will take more time than expected, to agree on maybe local decision or earlier decision in the way to stabilize ground truth elements for training machine learning system or exchanging data at a different stage. And so in that case, we may indeed consider this as an early stage RFC. So this is a good proposition. Let me see whether there are other questions. Can or should drafting RFC be included in a suitable Horizon project where TMO is a partner? So the question is whether we should have, I guess, a European project which will be fully focused on drafting RFCs. That's possible. It's important to say that the RFC process and the first planning is already the result of a European project, a one-year CSA project. We'll see exactly what is the global policy of the European Commission in the global planning on digital culture in the coming 10 years. If we were there for the webinar last week, you know that we are following and tracking these things with great attention, both in Brussels and in each country, following each of the calls. So this is a bit out of our control, whether that could be in itself the subject of let's say, an actual European support for these elements. We received already that support to some extent, and I think we need to show that the system is working already at that stage, based on the collective enthusiasm and wish to actually design collectively that machine. If we can prove that from a bottom-up manner, I'm kind of confident that getting a support for it afterwards will be much easier. Any other questions? Let me check here. Oops. Oops. So there's a couple of remarks on the conference that were presented here and there, and whether this was in the global horizon of Time Machine. I'm not sure exactly how to answer to such type of questions, in the sense that I mean, you probably saw in the last weeks that there are different dimensions, I mean, of Time Machines. Some really dealing with locality, some dealing with the way for supporting projects. We'll give in a month, more or less from here, with the Time Machine 2020 virtual conference, a kind of global sum up, where we'll come back on the webinars content, but also on the different, let's say, actions of Time Machine in the different countries. So maybe some of your questions will be answered at this occasion. Okay, I don't see specific questions on RFC. Let me just double check here. Have you developed or have running any data infrastructure? So the different answer on the question whether Time Machine has already any data infrastructure. There are really two paths for the innovation. One which is done, let's say, locally by the different partners. Many of the partners have currently data infrastructure currently running, with sometimes different format, different ideas, and they're sharing their concrete experience through the local time machine networks, with an effort in sharing best practice and converging toward good solution. The choice for the time machine as a standard structure is precisely what we're going to do at a slower pace in the RFC process. I mean, taking into account the experiments that were done locally and collectively agreeing on what should be, I mean, the right standards for this. And so this is probably the way we're going to proceed. So in the coming years, let's say. Let me come back here. We have a question. Is video content allowed to be included in an RFC? For the moment, it's not, let's say, it's not impossible in the sense that as part of the markdown format, you could, of course, put links to external let's say, resources. Let me maybe pass this to Daniel. What do you think? Do you think videos can be used as resources in RFCs?
Well, there are two different facets to that. One is the technical aspect, and one is from the point of view of the content. Technically speaking, as you said, of course, you can embed links to videos anywhere. Doesn't really make sense from my point of view to see a video itself as an RFC, because we're trying to use RFCs in the sense of formal documents describing something, some parts of the infrastructure, and that I think is very difficult in a video. But still, of course, technically it's possible. But yeah, we have not really considered actually to use that format. Also, audio recordings, of course, they are part of secondary content for RFCs, and in that sense, they are perfectly valid in whatever use they might be used in an RFC. For instance, to illustrate a specific part of the problem, many or several RFCs will be on the topic of using video content for several parts of the time machine, but that means the video would be a secondary part and not the primary part. I think if you have specific use cases in mind, it might be a good idea to contribute it in the form of an issue to RFC 3, so we can discuss it more in detail. For now, I would rather say I would prefer if the content of the video would be described in a textual form to make it more easy to store it, too easy to extend it, and to comment, of course, to it for additional users. So, but it depends. So, of course, you can make your point in the repository, and then we discuss it further if you like.
Thank you, Daniel. I think one thing which is also implicit is that we view the RFC as being something that progressively will become the code, in the sense that the RFC in some way is the collective design of what we believe should be the way of doing things, which get progressively implemented in some pieces of the time machine code. And so to have this careful collective curation of a content where we may, change a word by another, reorganize things. It's true that text is extremely powerful as a collective media, and that being audio or being videos are difficult to collectively, let's say, shape in the way we would like time machine to be collectively shaped. Okay, I don't see any more questions. Let me just double check here. No, if there's no additional questions, I think you have the information essentially to start and join us. If you want to participate in one of the 3 roles, being an editor, helping smoothing the process and managing the process, being a writer of RFC on specific topic, or being simply a reviewer actually helping RFC to get better over time, don't hesitate to write a single address, rfc@timemachine.eu. Don't hesitate already to post your issues on GitHub on the existing shaping of the RFCs. It was very important for us to share, this initial design choice at a very early stage of the process. It's an occasion also for anybody who wants to join at a very early stage of the process. Just think if you would be at the early stage of the RFC on the internet. That's an interesting moment where everything is possible. I'm thinking that obviously in the coming months things will get more and more concrete as we get into volume and more and more examples in terms of whether these initial choices are fine or whether we should try them. So I wish you a very good evening, and we will of course join together for Time Machine 2020, and I let now Caroline for the final words.
Oh. Thank you to you, Frederick, and also to Daniel to show us what can be done or how the process is for the moment to actively help us coming up with solutions for our time machine idea. So as Frederick said, feel free to contact us on the RFC@timemachine.eu email address. And of course, this webinar, as I said before, was recorded, so you can also review and rehear it anytime you like. We will share it on our website and also have the short presentations and maybe some more insight and information later on. So now I think the timing is good. If we really have no other questions, maybe if anything comes up, you can always contact us, as I said, on the RFC@timemachine.eu, or personally to Daniel or Frederick or myself. So thank you for watching us. And next time, maybe we will see each other at our Time Machine conference, which will be starting on November 23rd. It's a Monday, and lasting to November 24th. You will, of course, also get updates and information via our newsletter, so feel free to subscribe, and on our website, which is www.timemachine.eu. So thank you for your participation, and have a nice evening. See you. Bye-bye.